Hello, today I'd like to share my ideas and thoughts on the coronavirus app, which might be used in the future in order to evaluate certain risk groups. However, people are getting pretty nervous because they might have to share a lot of private information in order to get the system work effectively. So today I'm going to share a proposal which protects the privacy of each individual group or people using the blockchain technology. So let's start right away. In this proposal, we're going to use the Ethereum blockchain because Ethereum already makes things very, very easy by using smart contracts, which we're going to use later on. So at first, when a user enters our ecosystem, he needs to generate an address, a public address, and derives a contract from it. So the user needs to broadcast a transaction where a contract is going to be created. This contract holds the following properties. At first, there will be an array of other addresses, along with a Unix timestamp or more Unix timestamps. These arrays hold the Unix timestamps for all addresses where the contract or the user has made an interaction with. Another value this contract holds is if the user is infected or potentially infected. Next to this contract, we have a mapping of addresses from user addresses mapped to their contract addresses. This might be useful for later verification which user belongs to which contract. The third contract is a mapping of private and public keys. So this contract holds public keys to later verify if a user got infected with the coronavirus, but I will cover this later on. So let's start with the handshake. So if two users want to interact with each other, user A0, for example, will send his public key to A1. A1 is gonna sign the value of A0 and pushes it back to A0, where A0 creates a transaction which pushes this information to the contract. This contract will update, for example, the value of A-1 with the Unix timestamp. But what happens when a user gets infected with the coronavirus? If a user is tested positive, he will receive a private key in form, for example, of a QR code, which he needs to scan with his app. This is going to create a transaction where, for example, this public key is going to be invalidated. So it's not going to be used a second time. Afterwards, the infected value is going to be set to 1 for the infected patient, and the algorithm will scan this array and will keep track of which people are potentially infected and will update their value to a 1. Another very important aspect is the spam protection. So if a user broadcasts a transaction to the mempool, his transaction is going to be fetched by the administrator and added to the blockchain using the proof of authority algorithm. So that means the administrator has total control over which transactions go into the blockchain and which not. So however, it could happen that there are a lot of transactions broadcasted by some malicious users who want to flood the network or the mempool with unnecessary transactions. So the administrator will have a very hard work sorting this out. In this case, we're going to use a proof of work algorithm so that before each transaction is broadcasted to the network, the user has to generate a transaction hash which is lower than a certain difficulty. I would recommend using a time frame of 30 seconds so that each smartphone should be able to calculate this hash within this 30 seconds time frame. However, it might be possible for certain malicious users to get transactions into the blockchain. So if a user wants to create a new contract, it creates a lot of fake handshakes. This is going to be broadcasted to the network. It might be very, very possible that this network will be very isolated from the real one. So if there are real users who were interacting with each other over their smartphones, the fake network will probably be very, very loosely connected to some of those individuals. So it will be very easy to distinguish the real one from the fake one, and we can later on isolate it and invalidate this network. What is also very interesting is if the malicious attacker just lies about the Unix timestamp inside here, for example. If this is going to be faked, then the administrator who includes these transactions into the blockchain will very easily distinguish them from fake and real, because he has his own clock, and if they both drift off very vastly, they will not be included into the chain. So this is also very easy to verify a fake transaction from a real one. So last but not least, I want to sum things up and explain a few of the benefits of this proposal. So the first thing is that the network already exists. So it's very easy to use an Ethereum clone with proof of authority. The only small challenge might be to integrate the proof of work along with the proof of authority mechanism, but it should also be pretty easy to implement. Another thing is that it's very secure. The whole system is anonymous, and even the infected users will not have to share their identity or any private information. So thank you for your attention. I hope everything was clear. And if you have any questions, do not hesitate to reach out to me. I will happily answer every question. Thank you very much. Goodbye.